So we're going to continue our review of geometry by looking at triangles. So a triangle is simply a polygon with three sides. Alright, so a polygon is a geometric shape made up of segments connected endpoint to endpoint where there's no gaps and things like that. So you remember polygons from geometry, and then specifically when you only have three sides, that is a triangle. Alright, so let's start off with classifying triangles by sides. Okay, so there's three situations when you can classify a triangle by its sides. The first one is, let's say you have a triangle and none of the sides are congruent, and that is a scalene triangle. So a scalene triangle is a triangle with no congruent sides. Alright, the next triangle is, let's say we have a triangle with two congruent sides. And in this case, this is an isosceles triangle. And so this is a triangle with at least two congruent sides. All right, then the last type is if we have a triangle with three congruent sides, and this would be an equilateral triangle. An equilateral triangle is a triangle with three congruent sides. Okay, now you might have noted that when we wrote the isosceles triangle is a triangle with at least two congruent sides. So a good question is an equilateral triangle also isosceles? And the answer to this is yes. Okay. So an equilateral triangle is an isosceles triangle. However, we always call it an equilateral triangle. We always want to use the best name to identify a figure, and so we will always say equilateral, even though isosceles would be correct. Now, the reason this is an important concept is, back in geometry, when you were developing all these theorems for these triangles, you had a number of theorems about isosceles triangles. So for example, if you have a median, or if you have the altitude of an isosceles triangle from this vertex down to this base, then the altitude is also the median. So that was an important theorem, and we're going to use that theorem in trigonometry. Well, the same thing applies to an equilateral. I mean, if you have an altitude, it's also the median. So instead of recreating more theorems for equilateral triangles, we'll just say, well, we proved it for an isosceles, so it also applies for an equilateral, done. And so that's the idea behind saying an equilateral is also isosceles. All right, so now that we've classified triangles by sides, let's classify triangles by angles. All right, so the first one is if we have three acute angles, and this is an acute triangle. So it is a triangle with three acute angles. The next now if one angle is a right angle, that is a right triangle. So a right triangle is a triangle with one right angle. A triangle with one right angle. All right, the next one so in this case we have an obtuse angle in there, so we call that an obtuse triangle. An obtuse triangle is a triangle with a triangle with one obtuse angle. Sorry about that. Alright, so every triangle has to fit into one of these, acute, right, obtuse. There is a fourth one, and this is a special situation for an acute triangle, and that is, let's say we have a triangle with three congruent angles, and we can call this an equiangular triangle. So this is just a special case. So an equiangular triangle is a triangle with three congruent angles. All right. So next we're going to look at an important theorem that goes with triangles. And let's say we have a triangle here, A, B, C. And so the measure of angle A plus the measure of angle B plus the measure of angle C equals, and hopefully most of you just were able to come up with 180 degrees right away. And we're not going to prove that. Hopefully that's something you proved back in geometry. But anyways, this is the triangle sum theorem. Okay, And the triangle sum theorem simply states the sum of the measures of the interior angles of a triangle is 180 degrees. The sum of the measures of the interior angles of a triangle is 180 degrees. Alright, so I think I can squeeze in an example down here. Let's say we have this figure. So this is 100 degrees, 30 degrees, and x. And we want to find the value of x. Alright, so this is pretty straightforward. We know that x plus 100 degrees plus 30 degrees equals 180 degrees. So we have to use our knowledge that the sum of the interior angles of a triangle is 180 degrees. Now, of course, write that out. Show your work. So the next thing we're going to have is x plus 130 degrees is 180 degrees. And we subtract 130 from both sides, and x equals 50 degrees. And there is our solution. Good. So in this video, we reviewed the concept of a triangle, and then of course most of this has to do with the vocabulary. Understanding what an isosceles or an equilateral triangle is, or what an obtuse triangle is. And then we ended with this triangle sum theorem, which is an important theorem, which basically states the sum of the interior angles of a triangle is 180 degrees.